Hello students, let us try to understand registers in parallel. Registers in parallel. Now let us consider the management of the three registers joined in parallel with a combination of cells or battery as shown in figure 12.7. Okay, so they are the maintained. Make a parallel combination of XY of three registers having resistance R1, R2, R3 respectively. Connect it with battery, a plug key and a meter as shown in figure 12.10. Also connect a voltmeter in parallel with the combination of resistors. Plug the key and note the meter reading. Let the current be I. Also take a voltmeter reading. It gives the potential difference B across the combination. The potential difference across each resistor is also capital V. This can be checked by connecting the voltmeter across each individual resistor. See in figure 12.11. This are the register has been placed. Take out the plug from the key, remove the ammeter and voltmeter from the circuit. Insert the ammeter in series with the resistor R1 shown in figure 12.11. Note the ammeter reading I1. Similarly, measure the current through the R2, R3. Let these be I2, I3 respectively. What is the relation between I1, I2, I3? It is observed that the total current I is equal to sum of the separate current through each branch of the combination. I is equal to I1, I2, I3. Let Rp be the equivalent resistance of the parallel combination of the resistors by applying Ohm laws to the parallel combination of resistor. I is equal to B on Rp. On applying Ohm's law, each resistors I is equal to B by R1, I2 is equal to B by R2, I3 is equal to B by R3. From equation 12.15 to 12.17, B by Rp is equal to B by R1 plus B by R2 plus B by R3. So 1 upon Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Thus we may conclude that the reciprocal of the equivalent resistance of group resistance joined in parallel is equal to the sum of the reciprocal of individual resistance. Okay, means the resistance is inversely proportional to current. That is what they are saying. We may conclude that reciprocal of equivalent resistance of the group of resistance joined in parallel is equal to the sum of the reciprocal of the individual resistance. That is what. So we have seen that the series of circuit, the current is constant throughout the electric circuit. Thus, it is obviously practicable to connect an electric bulb and electric heater in a series because they need current of widely different value to operate properly. See example 1.3. Another major disadvantage of series circuit is that when one component fails, the circuit is broken and none of the component work. If you have used fairly light to decorate building on festival, on marriage celebrations, etc., you might have seen the electrician is spending lot of time in trouble locating and replacing the head bulb. Each has to be tested to find which has fused or gone on the other end. A parallel circuit divides the current through the electrical gadgets. The total resistance in a parallel circuit is decreased as equation 12.8. This is helpful particularly when each gadget has different resistance and require different current to operate properly. Okay, so that is what is our answers. That is the resistance is inversely proportional to current in parallel line. So that is what our answer. Thank you so much for watching.